Hello, and welcome to Pre-Calculus Lesson 9. This is when pre-calculus gets real, because we are beginning our proofs of congruency. Now, we already did proofs of similarity. All you need to do is show that three angles are the same within two triangles, and you have similar triangles. But for congruent triangles, you have to have some different things. And here are the different things that you must have. So, in order to get two triangles and to say with absolute certainty that they are identical, you must use one of these congruency postulates. So, we have one that is the side postulate. That is when you know that three sides are congruent between two triangles, then you know that the triangles are identical. So you need no angles inside. These two triangles are identical. In math or in geometry, we would call these congruent because they have three sides that are the same. Okay. Next, we can do it if we have similar triangles and one side. So this is the angle side. And in fact, since we have two angles in a triangle, we know the third is the same. We often leave out the first angle. So what does this look like? Well, if they gave you that this angle matches this angle, and this angle matches this angle, and this side is the same, then you know that those two triangles are congruent. They match. Okay? In this lesson, you're going to have to do a little bit of work to get to this point where you can show the two triangles next to each other with those same matching pieces. And then you can say by the side congruency postulate or by the angle side congruency postulate, these triangles are congruent. The other congruency postulates are angle side. Don't give me sass now. Just kidding. Sorry, that was bad. Something really important about the angle side. You could potentially spell, never mind, I'm leaving that out this year. I'm losing it, guys. All right, the idea is this. If you have one side, you have the angle between the two sides, and then you have a third side shared between two triangles, then those two triangles are identical. A word of caution. This angle must be between the two sides. Okay, it can't be on the outside. It's not side angle or angle side. It must be in the middle. Otherwise, it doesn't work. The final one is the hypotenuse leg, or HL. So what that requires, and there's like a hidden 90-degree angle in here. If you have a right triangle, and you know the hypotenuse, and you know the leg, then that guarantees that those two triangles are identical. So it's like the angle side postulate, although the angle is not in the middle. Since it's a right triangle, we know from the Pythagorean theorem that if we know two sides, we can find the third. So it actually fulfills all of these. Okay. Now, how are you actually going to do these problems? Well, this is what they're going to look like. Given side AD is congruent to BD, and side DC is perpendicular to AB, so they give you a couple of line segments that are the same, and then they give you a beautiful picture. So this is A, B, C, D. So what they're saying is AD, this one, is the same as BD. and they're saying DC is perpendicular to AB. They want you to show that AC is congruent to BC. Now, here's what I'm asking of you. I want you, for the purposes of this lesson, to identify which of these 4 congruency postulates work and draw out the triangles as I've shown here. So, since we are showing that AC, which is this one, is congruent to BC, I probably want to draw out the left triangle and the right triangle. So, your first step is to draw the 2 triangles that we are interested in. So, this one on the left, you must include the letters. So we have A, C, D, and the triangle on the right. We have D, that is not a D, B, C. Now, we're going to write in what we know. So, we know that AD is congruent to BD. We know that this is perpendicular to that, so these must be right angles. And we are proving that AC is the same as BC, so I can't use that as part of my postulate that I choose. So, I need some more information because right now I can't use hypotenuse leg because I'm proving the hypotenuse, so I can't use that as part of my proof. I don't have the third side right now, so I can't use side angle side. I definitely don't have 3 sides because I'm proving one of them. And I don't have all the angles. So what am I going to look for? Well, I'm going to go back to the original and say, what else do I know is the same from the original to these 2 that I've drawn? Well, I already have no chance of using the side, 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 or the hypotenuse leg. So I'm either going to be angle, angle side, or side angle side. Let's look at side angle side. If this were the case, I would need this side to be the same as this side. If we go back to our original, we see that DC is actually the same line. So when it's the same line, we're going to use this little circle to indicate that it's the same. And now I have a side, an angle, and a side. So now I'm going to write my conclusion. My conclusion is this. By the side angle side postulate, AC, now that I've proven that these 2 triangles are the same, that they're congruent, I can say that any part of the triangle is the same. So AC is congruent to BC. You guys are going to get tons of practice on this in your homework with tons of ugly, weird shapes. So I'll be praying for you guys for sure, and I know that you'll have a great time with these proof outlines.